Cylindrical alumina crucible, a high-temperature ceramic vessel made from high-purity aluminum oxide designed to hold solids or melts during calcination, sintering, and small-batch melting in laboratories and industrial furnaces. This is a container, a vessel built specifically to receive a sample on the inside. It is available to supply cylindrical crucibles in capacities ranging from 5 milliliters all the way up to 1,000 milliliters. In alumina purity grades from 96% up to 99.7%. For benefits, make cylindrical alumina crucibles essential for thermal processing. First, tight geometry machined to plus or minus 0.1 millimeter tolerance, keeping wall thickness and curvature consistent for predictable heat profiles and repeatable mass balances. Second, the dense alumina microstructure delivers chemical inertness, stable geometry, and reliable electrical insulation across repeated heating and cooling cycles. Third, the cylindrical form factor aids even flow inside the vessel and easy handling during loading and unloading, while the form can be tuned high form or low form to control evaporation. And fourth, geometrically consistent crucible series from 5 to 1,000 milliliters enable bench tubeless scaling without requalifying interfaces. The same crucible profile carries from small lab tests up to larger furnace batches. In chemical and laboratory work, cylindrical alumina crucibles are the standard vessel for routine calcination, catalyst preparation and activation, ash content testing, and drying and weighing sequences. The choice of form factor matters here. Low-form crucibles run faster cycles because their larger surface-to-volume ratio shortens heat-up time, while high-form crucibles are selected when splash control or draft control over the sample matters more. Two specific pain points show up repeatedly in lab procurement. The first is transit breakage. Generic packing typically returns 2 to 5 broken pieces per batch, which interrupts experiment schedules. The second is draft-induced inconsistency in mass balance during ash determinations. ADCERAX addresses both with chamfered rims and robust foam-protected packing that cuts handling damage, keeping yield consistent batch after batch. The another application takes the same crucible into more aggressive thermal territory, high temperature, sintering and small batch melting for sintering, ceramics, composites, and frit materials. The alumina vessel holds the powder charge through extended high-temperature dwell cycles without reacting with the content. For small batch metal melting, including precious metals, high purity alumina at 99.5% or above maintains carat accuracy and prevents the discoloration that comes from impurity pickup. The combination of chemical inertness, thermal shock resistance, and stable geometry across repeated heating cooling cycles is what makes alumina the default choice when sample purity cannot be compromised.